You see this strip here between the crop and the ground outside the field. That's a pixel. It may not look like it, but it is. There's pixels here. And there's pixels here. There's also pixels here and here. And I'm not talking about what we see on the screen. I'm talking about the way the map works. The map is actually a 3D displacement mesh, meaning it deforms vertically only, coated with a texture file, which doesn't literally look like the map image here, but is an applied texture file where the pixels' individual values are instructional data to the engine on what to display at that location. It's been this way in 17, 16, 15, 14, 13, 11, and 9. The big difference in FS17 is that when you have mission fields, they're an extra layer of information that works on top. Now this is a player field, so once I harvest this, I can go ahead and cultivate and sow in that edge pixel as well. And I'll get back to that in a little bit. But the image that the map uses includes the information on where the dirt texture, the open area texture, anything that's a ground texture instead of an actual object like the road over here, or specifically the sidewalk, is an applied spline. What a spline is it's a two-dimensional object that goes across the surface, or it can be three-dimensional, and it places in a specific. So you see how these lines go across onto this spline? These stripes are part of another spline. Or they could be an object, don't know. So this road is a spline, and you can see it actually has a bit of an offset, and it has an edge texture on it of dirt, which doesn't really make that much sense, except that the spline is designed to pull the dirt up to it along its edge, so it contains displacement information. That way you get a perfectly smooth surface for driving on, and you don't have to worry about what's underneath. Now, in FS17 we have the lizard roller, which will return our field or other damage we've done with the plow back to normal ground. It resets map grass back to completely mowed off map grass for it to start growing again. And that's where the alteration map comes in. If I was to say cut down those trees in that small area over there and plow it up, it would produce an alteration. That file has to be saved, and when the map loads, it loads the map data, then it loads the alteration data and the mission field data. The mission fields are handled in a different way from the map data, and they're actually applied to it as an after effect. But that edge there is a pixel. Now, in 15 or 13, if you've ever used the single row corn chaffer, the forager, and you cut down one row, it removes sometimes 2 rows of corn, but only one pixel width of the fertilization underneath. And that's because this object here, this square, of wheat is a 2x2 pixel object. It's centered around a random variation off the point between those 4 pixels. So that's why it looks like it grows everywhere. But that's why when you're plowing down a field, sometimes it'll reach a little bit further out from one side or the other side, or on some mod makers tools, say they're 3.7 meters, it will always do 4 meters. And that's because if I touch the pixel with the equipment alters the entire pixel. So the crop destruction module will destroy the entire crop in every pixel that the mapped location and width of the wheels touches. This can get a little tricky with the edge because textures have a slightly deviant behavior at an edge. We use things called normals, and the normal sort of decays at the edge of an object. That's why when you're dealing with polygons, the 3D modeling engines treat an object as a polygon, and that's for mapping purposes. When I actually say the word polys, I'm talking about triangles with textures on them. We used to call them texels, which was a textured triangle. So if I had a triangle that had a lighting texture, a gloss texture, a backlighting texture, and a bump map for dirt, that would be 4 texels that the engine had to deal with, even though it only displayed as a single triangle. So what we're doing when we play is we're using a really ornate mechanism to paint a texture. Pixels wide. You can even see the line down the center of it. So that's how the maps work, and that's why the care wheels still destroy crop. That's why when you're plowing along, sometimes you get more than one section. Now, say I'm planting crop going across a hillside. Because the equipment is actually tipped and the game uses actual physics, the equipment's cutter width, the active width, say it's I'm cultivating and it's a 4-meter cultivator. The cultivator's cutting width is the hypotenuse of a triangle, where because the game uses a vertically projected texture, the width is based, of the pixels, is based on the actual linear width along the ground. So if I'm on a 15 or 20 degree slope, I'm not actually going to be affecting 4 meters of ground. According to the texture, I'm only going to be affecting the side that's flat of the hypotenuse. The old A squared plus B squared equals C squared. That's how that applies. You run into this when you're using the GPS mod, which projects vertically a width on the ground. Yet if you're on a sloped hillside, your cutting width is not going to be the same. Now, since grass is now a field crop, Giants has added in the lizard roller. And what the lizard roller does is what used to happen when you used a seeder to sow grass seed. That would return it to the map state and would also plant grass across the roads. So now we can plant grass in a field, and we can weed it, and we can fertilize it, and we can harvest it, and we can get a much bigger yield from it. Or we can just rely on the normal map grass to provide for us with large mapped areas. Honestly, if you've got a very low-end system, it may be more advantageous to you to rely on the map grass by simply rollering a field down. It'll produce less yield, but the map process is much more efficient than the field process. If you have a high-end system like me, it's not really much of a concern. I'm actually playing at 4K, holding about 45 to 47 frames on admittedly a $1,500 graphics card on one of the fastest Intel consumer 6-core processors there is. It produces a lot of heat, but it produces a lot of resolution and leaves me a massive amount of CPU on the side to do recordings. This is being recorded at 18 megabits per second. It actually is recording at more than 3 times my maximum upstream load. So this 15-minute video is going to take 45 minutes for me to upload. But it's beautiful. So that's how the map works. It projects pixels straight down to define where textures are applied, and specific textures will grow specific things. And that's why when you turn down the detail level, the fields will turn back into a texture on the ground. It's very efficient, it's very effective at doing the level of detail, and it's advantageous that the game was designed this way, starting out with just textures on the ground, because it means that all the mechanics of the game will function correctly, even at minimum detail, even if you barely have enough computer to run. So that's the end of this video. I hope it was informative. I've been wanting to make it for a long time. I just never had the computer hardware necessary to do it. Y'all have a good time.